Dear students, the first chapter in the subject semiconductor devices, that is semiconductor diode, which carries you 25 marks, and those 25 marks are distributed as one question for 5 marks and two questions for 10 marks. You have to write 5 marks one question, and for 10 marks you have to write two questions. So, first here in this chapter I have listed the most frequently asked questions by referring the previous question papers, and I have listed the questions. Okay, go through these questions and answers, and also you refer the notes what I have given in the class and prepare. The first question is, list the applications of the diode. So, what are the different applications of the diode, where the diode can be used? The main application of the diode is in rectifiers. So, that is the diode is used as rectifier. So, what is a rectifier? The rectifier is a circuit which converts AC signal into DC signal. That is the signal which changes its direction on the alternate sides, that is from positive to negative frequently, is converted into DC. That is the DC signal has only one side, that is either positive or negative. It will not fluctuate between positive and negative. So, how the diode can be used as a rectifier we will see in the next slides. Okay, the first application is the diode is used as a rectifier. So, the second application of the diode is the diode can be used as a switch. So, how the diode can be used as a switch we will see in the next slides. Then the diode is used in communication circuits. The diode is used in wave shaping circuits. So, the characteristics of the diode, that is which conducts in forward bias and do not conduct in reverse bias, this property of the diode is used in wave shaping circuits. Okay. Next question is, explain the VI characteristics of the diode. VI, that is voltage current characteristics. So, how the current flows in the diode as we give the voltage, what is the behavior of the diode for different voltages. So, here the diode characteristics can be plotted in two ways. So, one is forward characteristics and one is reverse characteristics. So, forward characteristics is nothing but it is the plot of voltage across the diode into the versus current in the through the diode during forward bias. So, what is forward bias? So, the forward bias is nothing but connecting, or what is biasing simply. So, biasing is nothing but connecting a battery to the diode. How we connect the battery to the diode? There are two types of biasing, one is forward bias and one is reverse bias. So, the forward bias means connecting the battery to the diode such that, or how the battery is connected to the diode in forward bias is, the positive terminal of the battery is connected to the P type of the diode and negative terminal of the battery is connected to the N of the diode. The P layer of the diode is connected with positive of the battery, N layer of the diode is connected to negative of the battery. Simply connecting positive to positive, negative to negative is forward bias. Okay. In the forward bias, what happens? In the diode, when we join P and N material, that joint is called as a PN junction diode. Okay. When the joint is formed between P and N type material, the P material has holes as the majority carriers, whereas N material has electrons as the majority carriers. When P type and N type both are joined together, some of the electrons from N side cross over the junction and some of the holes from the P type will cross over the junction and will form a potential barrier. That potential barrier is called as a barrier potential for the conduction of the diode. So, that barrier potential will be 0.7 volts for silicon and 0.3 volts for germanium diode. Okay. So, during the forward bias what happens? The positive of the battery is connected to P layer, negative of the battery is connected to N layer. The holes which are the majority carriers in P layer are repelled from positive of the battery and they will try to move towards the junction, whereas the electrons which are the majority carriers in n type are repelled from the negative of the battery and they will try to move towards the junction. So, as a result, as the forward voltage is increased, the electrons and holes, because of repulsion between the same charges, will try to cross the junction or will try to move near the junction. So, as a result, the potential barrier goes on reducing, the potential barrier goes on reducing. So, the battery voltage which is equal to the barrier potential, when it becomes equal to the barrier potential, the potential barrier is completely eliminated and the diode starts conducting, So, the current starts to increase rapidly. The circuit diagram is shown in this slide, that is positive of the battery is connected to positive of the diode, negative of the battery is connected to negative of the diode. The voltmeter used to measure the voltage, the voltmeter here is used to measure the voltage, the milliammeter used to measure the current through the diode. Okay. So, next coming to the reverse characteristics of the diode. When the diode is reverse biased, the reverse characteristics is plotted. The reverse characteristics is plotted by taking the voltage across the diode and current through the diode. What is reverse bias? Reverse bias is nothing but connecting battery to the diode such that the positive of the battery is connected to n layer, that is negative of the diode, negative terminal of the diode, and negative of the battery is connected to positive terminal of the diode, as shown in the circuit diagram here. As shown in the diagram, positive is connected to negative of the diode, negative of the battery is connected to positive of the diode. So, here what happens, as positive is connected to the n layer, the electrons which are the majority carriers in n layer will be attracted towards the positive of the battery and they will try to move away from the junction, and the holes which are the majority carriers in p type material are attracted towards the negative of the battery and they will try to move in the opposite direction, that is away from the junction. So, as the reverse voltage is increased across the diode, the electrons and holes in the n type and p type will try to move away from the diode. So, potential barrier goes on increasing, So, the diode will not conduct or diode will act as a insulator. Now, at a reverse voltage which is equal to breakdown voltage, the junction of the diode breaks down and diode starts conducting rapidly and the current increases rapidly. That you can see in the characteristics plot. In the forward bias, what happens? The current, as the voltage is increased, slowly the current starts flowing, and at the point phi k, that is knee voltage, the junction is eliminated, this potential barrier is eliminated and the diode starts conducting. During the reverse bias, you can see as the reverse voltage is increased, a very small current flows through the diode, and at the point when the applied voltage reaches equal to the breakdown voltage, the junction breaks down and diode starts conducting rapidly. Then next coming to the Zener diode. What is Zener diode? The Zener diode is similar to the diode, but only the difference is the Zener diode is having very sharp breakdown voltage. During the reverse bias, the Zener diode has very sharp breakdown voltage, that is when the breakdown voltage is reached during the reverse bias, the current remains, the voltage remains constant, okay, and current increases rapidly. Voltage remains totally constant. So, here also there are two types, forward bias and reverse bias. Again the same, forward biasing is nothing but connecting the positive of the battery to the positive of the Zener diode, negative of the battery is connected to the negative of the Zener diode, and during forward bias the characteristics are same as that of semiconductor diode, but whereas in the circuit diagram it is shown here for forward biasing of the Zener diode. Then in the reverse characteristics, okay, the circuit diagram is shown in the diode in the slide here. The positive of the battery is connected to the negative of the Zener diode and negative of the battery is connected to the positive of the Zener diode. So, during the reverse bias again the same thing happens. When the breakdown voltage reaches, that is Zener breakdown, that is called as a Zener breakdown. At Zener breakdown the voltage remains constant and current increases rapidly, that you can see in the characteristics here. In the forward bias the Zener diode acts in the similar manner as that of ordinary diode, but in the reverse bias when Zener breakdown voltage reached, the current voltage remains constant and current increases rapidly. Okay, now coming to the how a PN junction diode can be used as a switch. Okay. So, as we have seen in the first slide, the diode can be used as a switch. How the diode can be used as a switch? We know that in forward bias the diode starts conducting. In reverse bias the diode acts as a insulator. The same property is used for using diode as a switch. So, here if the AC supply is given, okay, as shown in the figure, for the positive half cycle of the AC signal the diode acts as a closed switch, because the positive half cycle of the AC signal makes the diode forward biased and the diode acts as a closed switch. Hence, there is a current through the load R, and at the output we can see the input signal appears across the output signal. Whereas, during the negative half cycle of the input supply will make the diode as reverse biased and the diode do not conduct, the diode acts as a insulator or the diode acts as a open switch. So, the negative half cycle, during the negative half cycle there is no current flow through the load resistance R, and hence the negative half cycle is eliminated at the output. So, here you can have the diode as a on off switch. During the positive half cycle the diode acts as a on, switched on, and during the negative half cycle the diode acts as a switched off. Okay. Now, how we can distinguish between Zener breakdown and avalanche breakdown? The avalanche breakdown, as the reverse voltage increased, minority carriers acquire large amount of energy. When these charge carriers collide with other atoms, break the covalent bond, therefore additional charge carriers are generated. They further produce more number of charge carriers and result in large reverse current. This reaction is called as a avalanche breakdown. Whereas in Zener breakdown, this type of breakdown occurs in heavily doped PN junction diode. When the reverse voltage is increased, the electric field at the junction also increases. Higher electric field causes covalent bonds to break. This reaction is called Zener breakdown. Now, coming to the how the diode, coming to the point how a Zener diode can be used as a voltage regulator. As we have seen in the reverse bias, if the Zener diode is used in the reverse bias, then in the reverse bias if the input voltage is increased and when it reaches to the Zener breakdown, the voltage remains constant and current increases rapidly. So, this property, that is the voltage remains constant irrespective of any increase in the voltage, that is after Zener breakdown if the input voltage is increased, the voltage across the diode will not increase, it remains constant. So, what is regulator? The regulator is a circuit which gives a constant output voltage irrespective of any changes in the input voltage. Okay. So, for this application the Zener diode is most suitable in reverse bias. Okay. The circuit diagram of Zener diode as a voltage regulator is shown in figure. So, the Zener diode is used in reverse bias. As the input unregulated input voltage is connected, the output voltage remains equal, that is output voltage is always equal to Vz, that is Zener breakdown voltage, and even if the input voltage is increased more, the output remains equal to the Zener breakdown voltage. So, here at the output we are getting the constant voltage irrespective of input voltage increases. Thank you. So, these are what the questions which will appear in the examination, most probably asked questions. So, the questions and answer both are given here. Refer this, refer the notes also, and be prepared for the examination. Okay, and all the best. And if any queries, please text me or you can directly call me so that the doubts can be clarified.